Hey there, welcome back to Coding at Home. Hey there, welcome back. I'm Matt with the Code Hub. Welcome back to Coding at Home. We've been through a roller coaster ride with Sonic Workshop. We've laughed, we've cried, and now we're ready to put it away. But before we fully put all the stuff we learned in Swan's Quest away, we're going to go back to, or in Sonic Workshop, we're going to go back to Swan's Quest. I'm jumping the gun. And we're going to look at some of those early chapters that maybe we struggled with a little bit when we first got to them. Like chapter 2 introduced some really difficult concepts for us because we hadn't had the background of Sonic Workshop under our belt. So we're going to go back to chapter 2 today of Swan's Quest. We're going to go over some of that code and see if it makes any more sense now that we've seen it in action in Sonic Workshop. And then we're going to move on to our next project, the next thing that we're going to be working on, which is a little thing called Sensor Arcade. These things are amazing because not only are they good for watching movies and emailing your friends and texting your friends and playing all sorts of games on apps and watching TikTok and everything else, they're actually great tools for coding, as we've seen, but they have all these sensors. They have the camera, so we've written a camera app, so we know about the fact that we can take pictures. But with the camera comes a thing like a light sensor, so we can detect the brightness or dimness of the light. We can detect things like sound using the microphone. We can use there's an accelerometer inside the iPad, so we can detect when someone has tilted the iPad. And then we also have this big, beautiful touch screen, so we can kind of feel when someone has touched where on the screen. And we saw a little bit of that with Sonic Workshop. So when we get into Sensor Arcade, we're going to start to explore the iPad as more than just a screen for us to look at and maybe do some coding on. It's going to take into account all the sensors that are available on the iPad to us. So before we do that, though, we're going to visit our old friend, the Swan. So let's go over to the iPad here that I've been waving around like crazy. That's why we're sort of resetting ourselves. If you lost your copy of this for whatever reason, that it happens, or if you wanted to start with a fresh one, you might remember we had our feed for this kind of thing. So you can go off to Safari. You're going to go to thecodehub.ie/playgrounds. And we still have that big, beautiful button there to subscribe to the WWDC feed. So you just tap on that. It would ask if you want to subscribe to it. It's basically just, it won't ever change from now on. There are no additions to this, to the Swan's Quest playgrounds. There are no new Quest Create playgrounds or anything like that coming that I know of anyway. So you can hit subscribe. It'll always, for the time being anyway, look like this, where we have these 6 playgrounds. So Color Quest, Quest Create, and then chapter 1, 2, 3, and 4 of Swan's Quest. So the one we're going to work with today is this Swan's Quest chapter 2, A Time for Tones, because that's where things jumped up that little bit in difficulty. I loved chapter 1. I thought the accessibility stuff they covered was amazing. And then chapter 2 did throw us in a little bit to the deep end, and it introduced dispatch queues and it introduced timers. And we're going to talk about that a little bit today when we look at that playground. So here, I'll get a fresh copy, and then we'll also look at our old copy that we worked on. So while that's downloading, we'll also go check out the developer app. So you remember during WWDC week, I got very excited about this because this is where we went to go watch a lot of these videos. All of those videos are still there. You can go up here over to the collections arrow. And if I go back again, we'll see what you see at the very start. It'll show you what you've been in the middle of watching. But if you want to find specific WWDC 20 videos, you'd look in the collections item, hit WWDC 20. And then you can see there's augmented reality, adapt your iPad app for Mac Catalyst, designed at WWDC. And if you tap into augmented reality, it'll show you the different sessions that they ran covering augmented reality. So ARKit 4 was announced at WWDC 20. What's New in Reality Kit is an entertaining one to watch. Shop online with AR Quick Look. The Artist AR Toolkit. So it talks about Reality Converter and Reality Composer. And then it talks about some of the formats that we use to build 3D content to be shown in augmented reality scenes. The one that we're interested in, of course, is if we keep going down, you'll see an option for take Swift Playgrounds to the next level. So this is relevant to us because we've spent nearly all of our time playing in Swift Playgrounds. And it tells you how to build a Swift UI view in Swift Playgrounds, which is a good session to watch if you're interested in learning how to build apps with a new technology called Swift UI. This is all about creating Swift Playgrounds content for iPad and Mac, which is kind of interesting. But this is the one that we played along with most, this Explore Swan's Quest. And it still has the 4 chapters, starts out with Voices in the Dark. Then we jump to chapter 2, which is only 5 minutes long, the video. So it's pretty quick to get through. And then we have chapter 3 and chapter 4. So if we wanted to, we'd go back here and we could watch. If we tap on this Swan's Quest, we'll see they've got a transcript of the video. So we could just read through it if we didn't want to watch the whole video again. They've got a code tab, so we can see some of the code that they showed on the screen, which is useful because we can just now copy this and paste it into our Swift Playground. And if we go back to the overview, we can search the forums so we can talk with other people about this particular playground and this challenge. We can look at the greater Swan's Quest forums and the discussion around those. We can download the Quest Create Playground book, or we can download the Chapter 2 Playground book. So this is another way of getting the playground on your device. So that's the developer app. It's still there. It's still got all the same great content it had 2 weeks ago. Definitely worth checking out and definitely worth revisiting, especially as you learn new technologies. Maybe it'll give you the idea for the next thing you want to learn about. So let's go back to Swift Playgrounds. And we'll take a look. We'll wait for our guys to load here. Here's the playground we just downloaded. So I'm going to tap and open that one. Okay, and if we wait for a second here. Actually, if we don't wait for a second, let's hit run my code and let's check it out. This is where we get advice from the lizard about how we want to solve this particular challenge, because we're going to go visit the swan and we need to play certain notes for that swan. So let's press play to play. Okay, and remember, this is where we got our notes in the form of numbers. And if we scroll through, the lizard says, yep, I've seen these numbers before. They're frequencies of different sounds. They talk about musical notes and how we're going to play them. And we saw this tone output here in the Sonic Workshop playground. In the very end, we played around with Add Cave Glitter, my personal favorite function name ever. We played around with adding a graphic cluster. And then we had another one where we would add tones. So we would add a bunch of images and they would play different tones when you tapped on the images in the cluster. So this is to turn these numbers into an array. We have to grab all those numbers and use a timer to loop through them. So you'll remember maybe, here we'll see. So inside of the timer loop, so if we go back we're going to try to write this code again here. So inside of our performance, we're going to do capital T for timer. And I'm just copying along with what the lizard is talking about right here. So timer.scheduled timer with time interval repeats. So I'll start typing in scheduled. And you can see here in autocomplete, it says scheduled timer with time interval. And we pass in a time intervals, just a number of seconds to wait. Here's the repeats parameter. And then we have this block parameter. And it's got a parentheses around a timer, closes the parentheses. It's got a dash greater than sign void, which is, remember, we saw that in the Sonic Workshop. That was a return. So it's returning void, which is nothing. And then it closes the function parameters. So this scheduled timer actually takes a closure that we learned about in the Sonic Workshop. So let's tap on that. We'll specify a time interval. So let's do 2, say. We'll say, yeah, maybe we won't have it repeat. We'll just have it fire once. Now, if we hit return, so if I'll show you what I did. So I was here, and when you tap on timer void, this whole function definition, or this closure definition, because remember, a closure is just an unnamed function, it highlights in blue. And when I hit the return key down here, it auto fills in what the structure of my code is going to look like. So now it's left me highlighted in blue over this timer type. So I just need to give it a name, right? Because that's my parameter that this timer function is going to pass in. So I'll just call it timer with a lowercase because it's not the type. If I did an uppercase T here, it would get confused because it would think that I was referring to the actual type timer. So let's see. So now this is where we're going to write our code. Well, before, what we did was we used the tone output to play a sound. So we'll play a tone. And let's say tone, and then we have to create one. So we use the parentheses to get our initializer for a tone. And we can use this initializer where we specify a pitch and the volume. Let's do that. Let's say the pitch will be, I have no idea what that actually will sound like. The volume will be 100, say. And this, let's try running it. Now we'll hit play. Now I'm a little bit surprised that this ran because we do have our capital T for timer. I would much prefer to just have the lowercase t so I can differentiate it between my variable and my type. So let's try hit and run my code again. All right, so Swan's Quest, press play. There we go to visit the lizard. He says these are frequencies of different sounds. The dog is very excited about this particular piece. All right, so we can use a tone output. We've shown you the timer and the scheduled timer function we can call and hand it a closure to be run. So what happens is at the end of this time interval, the timer says, hey, run this code, this closure that someone passed me. So this is what we're going to play. Now we kind of inline this. Instead of saying middle A is 440, we actually just created the tone inside of our call to the play function. So let's practice that. Let's see if we succeeded. All right, so Sounds like an emergency system. Maybe volume 100 is too much. 0.3, and let's try changing this to, I believe it was 440.0. Let's try that. Let's run our code again and check it out. We'll hit play. There we go. We go talk to the lizard. The lizard talks about the scroll and the frequencies of different sounds. It's the major scale, so we can use a tone output. We can use a timer to loop through them. Our tone is very similar, so 440.0 and 0.9, and we immediately have it play the tone. Instead of reading a note here, they create a variable milli that they assign the tone to. We hit this button. Practice that right now. Let's go. Oh, way better. Great. Okay, so we just need, the only thing we need here now is stop the noise, which they told us how to do in the video. Now I haven't watched the video in a little while, so what I can do is I can go back here, and I'm just going to do a quick switch here. I'll give you a quick wave, and then we're going to transition back to the iPad to see if we fix our lag. So here's my completed version. So you'll see that what we did here was we used a timer in our performance at Swan Hall. We had an array full of pitches that used all of this array of numbers that the lizard wrote down for us. We created all of our tones. And then we used that schedule timer to loop through and play all of our tones. And then when we ran out of tones with this guard statement here, we said, okay, tell this tone output to stop the tones, invalidate the timer, which basically just says stop looping because we have it to repeat true. And then we tell the owner to end the performance, which kicks off a whole analysis of how our code performed and whether or not we had the right elements in our code. If we go back to the original, when we watched the video, they actually proposed that we use something like this dispatch queue dot main async after, and then we gave it a deadline. And here, let's open this up so we can see it all on one line. We gave it a deadline of .now, which is just, it'll give you the exact time of now. And then we added a dispatch time interval of 400 milliseconds. So just less than half a second. And then we called tone output stop tones. That's what stopped that noise from playing continuously. So we have this A4 here. We play the tone, and then this basically says, hey, you're going to do something after. A lot of places that we use closures, because this again is another closure. This async after, if we actually try typing that out again, we'll start typing dispatch queue again. So with a capital DIS, dispatch, and here it is over here. We'll do main. And we'll tell that main thread, and I'll explain what that is in a second, to do async after this. And if we look at this function here that we're calling, we give it a deadline. There's a deadline parameter that we use up above. And then we have this execute parameter. That's an open and close parentheses, so no parameters. And then it returns a void. again. And that's what we've done here, is we have this, that's our deadline parameter. So this whole .now plus the time interval. We close the parentheses, and then our closure, that last parameter, we include that code that's going to be run after so many seconds after the after so many seconds. We include the code that we want to be run. So this stop tones, which tells the tone output to stop producing that noise. So let's tap on this one and we'll try that again. So what we did was .now is just a type. So we could use distant future, which would mean that it would take a really long time for stop tones or whatever code we write in here to be called. So we'll do now, and then we'll do plus to give it a little bit of time extra. To create a dispatch time interval, we'll use the dispatch time interval type. And then you can specify whether it's in microseconds, milliseconds, nanoseconds, regular seconds. So we can maybe say regular seconds, and we'll have it do it after 1. And now if I tap on this function definition, it highlights it as blue. And if I hit return, well, it does nothing for me this time. But now I can use my braces, and now I can tell my tone output to stop tones. So I'm actually going to delete this one, and we'll try out our new code. I'll hit delete. We'll select this as text and delete this entire line. And we'll see that this looks a little bit different than the other one. This is just another way of being able to write a closure. Swift lets you drop this execute parameter because it's the last parameter. In fact, this has even changed recently, but we won't worry about that. We can actually take this parentheses here, closing one, put it up behind our first parameter, and then say that second one, that last parameter that takes a closure, we can actually put that inside its own braces. I personally prefer that. I think it looks a little cleaner. But when you first come to it, maybe you might say, well, I'm not sure why is that hanging off the end? When it's as parameter, it should be inside these parentheses. Well, let's try running this anyway and see what we have. We'll hit play. There we go to talk to the lizard again. The lizard says, yep, gift from nature, yep, frequencies of sound, tone output, yep, cool, time interval, which we did in the other playground that we just downloaded. And we're going to practice it. So here we go. Nice. And so after a second, we stopped the tones and we did everything we needed to perform for the swan. So this is basically like a lot of the code that we were writing in Sonic Workshop. The reason why you use closures, especially in this case, is that the iPad is smart enough to be able to do more than just one thing at once. It's got multiple threads, we call them in programming, where it can do certain operations on one thread. In fact, anytime we draw things on the screen or move things around the screen, we use the main thread, as it's called, because that's the one that's given highest priority, and it's doing all the visual updates on your screen. And we can have other threads running on the background that go off, and maybe they talk to someplace on the internet. Maybe they go load a file, because sound files can be kind of large, or image files can be kind of large. Maybe they load something on a background thread, and then when they're ready, then they can go and perform something that'll update the main thread, and we'll be able to draw it on screen. I'm going to try to illustrate this with a video that I don't have ready quite yet. But it is a fascinating thing with programming, this whole multi-threaded programming idea. It's the source of a lot of bugs. But I really like the whole dispatch queue framework that Apple has for handling threads and handling different tasks that you want the iPad or the phone or the Mac to run. So that's revisiting our old buddy Swan's Quest. Hopefully this makes a little bit more sense now that we've done Sonic Workshop. And the next thing we're going to play with, we're just going to download it now and maybe take a quick look, is a playground called Sensor Arcade. So we're going to go off to more playgrounds and we're going to hit see all. So when we bring that up, we're going to be playing again in this challenges area. There's a playground here called Sensor Arcade. So we're going to tap on that. It says it's an intermediate playground, which it is because it uses a lot of the same concepts that we've been using in Lights Camera Code and in Sonic Workshop. So what we're going to do is we're going to get this playground. And if you get this now, you'll be well set up for our sessions over the rest of the week. Almost there, it's coming. And like I was talking about earlier, this is the playground where we get to really use all the sensors on an iPad. All right, so now that it's downloaded, we're going to tap on it and we're going to open it up. And we have a little introduction. So it tells us all about using device sensors. And if we scroll through, it tells us all about the sensors that are inside of the iPad that can detect things in their environment. Right, there's the audio sensor, the microphone that can detect noise. As we saw with Sonic Workshop, the iPad screen can detect every time we move. So we have the light sensor. So the camera, which can sense dark and can adjust itself, we can handle in code accordingly. And it mentions here that when a sensor detects a change, it sends a message called an event. Now we've dealt with event handlers before in Sonic Workshop, even in Lights Camera Code when we were handling button presses. And so these events are going to send us information, like in this case, color, for our handle light update. And you'll notice that we have on our light sensor, we do set on update handler, and we hand in this function. So it's not a closure, but we're passing in the name of this function. Just like we did when we connected our buttons in Lights Camera Code. And so we call those things event handlers, that code that we've written to be our on update handler or on touches move handler. So in this case, we get a light passed into our handle light update that's a type of color. And if we say if the green component of that color is greater than 0.5, then we rotate our player, which is this giraffe, by 360 degrees for 1 second. So while we're working through this playground that we'll be doing tomorrow, we can choose two different modes. We can choose play or practice. Typically, I start out in the practice mode to see if my code's doing what I expect it to do. And then I switch over to play to see what kind of score I can get. So I'm going to hit start coding here now, but this is going to be the end of our session for today. Because what we're going to do tomorrow is we're going to handle touches. And we've got all sorts of cool new functions and methods we can call on different objects. We've got a handle touch moved function that we then set as our on touch moved handler. And then we can also set the page difficulty as well. So we'll play around with that a little bit. So that's what we have to look forward to tomorrow. If we tap up on the table of contents up here, so if we tap on Catching Cupcakes, we can see that we've got a few different ones. Dashing Donuts, Sound Poppers, Bumper Bash, Gem Hunter, and then What's Next. So once we're done with this playground, we can start to look at some of those other base playgrounds like Sensor Create, like Sonic Create, where we can really start from a kind of from scratch and build our own experiences out. So that's for tomorrow. I hope you're excited about that. I love Sensor Arcade. I think it's a brilliant addition to the Playground family. And I think we'll have a lot of fun doing some really interesting things with our iPads. All right, so until tomorrow, hope you enjoyed this session. Happy coding, and like and subscribe if you will. Thanks. Bye.